Hello everyone, welcome to my YouTube channel. So guys, in this video, we are going to take a look at what is adjusted R squared and the relation between the adjusted R squared and the R squared, right? So in the last video, we had discussed about the what is R squared, right? In an explanatory manner, we have discussed about the R square. So in this video, the beta metric term in machine learning, which is adjusted R square. So what is it? And the relation between the R square and the adjusted R square, for sure, right? So anyway, I am repeating what is R square. So R squared is the quotient of determination, right? So the formula we have discussed, that is 1 minus residual sum of squared down total sum of squared, right? So this is the R squared. So guys, if you haven't watched that video, please go and make sure that you have watched that video so that you can grasp some idea from that, right? Okay, so hope you guys have watched that video. So let me continue about the adjusted R square. So we have learned about the R square. So now let's focus on the adjusted R square, right? So adjusted R square formula is nothing but 1 minus R square, or coefficient of determination, into n minus 1 down n minus p minus 1, right? So this is the basic formula. You could wonder, we have R square, right? A metric term. Why the hell do we have to go this adjusted R square? Of course, right? There's a reason. R square is a nice metric, but there's an issue. Because of that issue, we are looking at this adjusted R square. So the issue is, so when we increasing the features, right? So when we increasing the features for the same problem or the same model or the same data set, if we increase the features, the R square will be reducing. So that will make you may think like, okay, so what? Just increasing the features. But the issue is, if we increasing the the features, it will reduce the R square, but it gets overfitted because all the features we do not need for a training or the model preparation, right? We have to select the feature. There will be a feature engineering and feature selection part, right? So using that features only, we have to build our model, right? So it's not good to increasing the number of features. So that's why we come up with this adjusted R square. So adjusted R square won't change if we increasing the features. So adjusted R square is a better metric than R square. So here we have R square. That's what we already know. What is this N and P, right? So N is the total sample size, right? So if you have 1 lakh of data points, that means N is going to be equals to 1 lakh. If you have 10 millions of data points, then capital N will be the 10 million, right? And then P will be the number of independent variable, right? Number of independent variable. That is our features that we are going to use for the model training, right? So using this N and P, we are making a better term, better metric term. Better metric term than R square, right? So this is what the adjusted R square, right? So we have discussed what is adjusted R square and why we have to go for the adjusted R square. So next, yeah. So next, we take a look at relation between the adjusted R square and R square, right? What is the relation between the adjusted R square and R square? Basically, adjusted R square is always less than or equal to R square, right? So here I have make this adjusted to ADJ for the easiness, right? So what you have to know is this: adjusted R square will be always less than or equal to R square, right? So guys, I'm going to finish this video now, right? So in the next video, I'm going to prove that, of course, adjusted R squared is always less than or equal to R squared using this formula, right? So until that, you could make a try and try to prove this adjusted R squared is always less than or equal to R squared, right? So hope you guys are doing fine, and I'm going to see you all in the next video. And if you really like this content, please like this video, subscribe my channel and press the bell icon, and also share with your friends, right? So that will keep motivating me to do a better job at making these videos, right? So until that, stay working and keep learning and keep doing well. Keep enjoying also. All right, guys. Bye.